and I can do a quick introduction to myself. Does anybody know me already? A few people nodding. Yeah. Hi. I'm Dave Sire, and I work for VMware, Spring Source, whatever you want to call it these days. So I'm kind of one of the Spring, open source engineers, basically. Started life with Interface 21, as it was then, Rod's company, and at that time when I first joined, I took on Spring Batch as my project. So anybody who knows me might know me as the Batch guy. And so I've done a lot of work on Batch, integration, core framework, and just recently, last year, I gave my first talk at SpringOne on this kind of stuff, on identity management. And that's basically what I've been doing for the last, I guess, 12 to 15 months. And I've been doing that in the context of the identity management solution, which is part of Cloud Foundry. So anybody here heard of Cloud Foundry? There might be a few things going on out there that are Cloud Foundry related. Well, I work on that team, but one of the tools we use is Spring Security, basically. So this is called sort of a Spring Security talk, but with Cloud Foundry as a showcase, if you like. But I would also like to leave you with the impression, and it would be more than an impression, hopefully, that what we've built for the Cloud Foundry platform is actually pretty useful generically, and you could just take it and use it wherever you wanted to have an OAuth2 provider, and that's kind of what I'm going to be presenting it as. And I'm going to set that all in the setting of, well, the question actually that was posed in the official title for the talk was when and why would I use OAuth2, so that's hopefully what we're going to get to the bottom of. Now, it's a little bit difficult for me because I can't see what's over there on my screen, so everything I'm going to do is going to have to be driven over here because of the AV constraints we have. But this is basically what we're going to do, right? So we're going to try and get to what OAuth2 is a little bit. I'm not going to go into a huge amount of mind-numbing detail on that, but I want you to kind of get to grips with it, get some hands-on. Through examples of showing code that implements it, I'm going to show you what it would look like if you were using Spring to implement it and to use it. And probably through that, give you an impression of what I would think of would be the easiest way to be an OAuth2 provider or consumer using Spring or other things. So I've got maybe, it depends how much time we have, how much I'll show, but I've got some Ruby samples and some Grails stuff that I can show as well. And a lot of what I'm talking about was just published last week on a blog, which is the link at the bottom there. I'll give you some more links at the end for more reading matter. So, what can we say? Where are we going to try and set the story? Well, we're going to try and set the story against this backdrop. This is an old Rod Johnson trick. He used to like to show these Indeed.com graphs. So this shows the growth of job advertisements, mainly US-based, I think, from the Indeed.com. Comparing JSON REST, which is the orange line, with SOAP XML, which is the blue line. And it's relative, so there are actually more jobs with SOAP and XML, but they're flat, right? And JSON REST is all increasing. So that's a trend. So that's just telling you that, everybody's sort of out there thinking about how to build larger, more complex systems, and you can hear a lot about that in this conference. I'm sure we'll go to any talk about Spring integration, any talk about Cloud Foundry, you'll hear about the kinds of systems that are driving this growth. And so really the question is, what if you're going to build one of those things, what are you going to do about security? And so hopefully this will provide you with some things to think about, if not the answer. And so again, framing the language, the terms I'm going to use. So I'm going to talk about lightweight services to sort of avoid using some sort of loaded architectural terms, but this is sort of what I mean by that. This is the trend, right? People are building, composing large systems out of these lightweight services, which are, generally speaking, using HTTP. should be, I should say, as a transport. Text-based messages, usually small amount of data passing between the components in these systems, often in some sort of human readable form like JSON. XML isn't as popular as it used to be. Certainly REST has an influence on these architectures, but I think I would be overstating perhaps the claims of some of the Cloud Foundry components, for instance, and certainly the one that I work on, if I said it was truly RESTful. I mean, we could debate what that means forever. So to avoid getting into a debate about that, I'm just going to say it's at least inspired by the RESTful principles, which probably means some degree of statelessness, but as we might see as we go through the presentation, the more security you put into things, the kind of less stateful, the more stateful they sort of become, or the less cacheable they become, at least anyway. And one of the main drivers, of course, is interoperability, which is why you've got these human readable and sort of JSON lightweight messages flying around everywhere. So people want to consume these services that you might want to develop it in Ruby, Java, Microsoft, .NET, whatever, and then consume it in the opposite. And that's a very common state of affairs these days. And certainly from the Cloud Foundry team, that is very much the standard way of doing things. Everybody writes a service. It has these characteristics, but nobody really cares whether it's written in Ruby, Scala, Java, Grails. All of those are in use in some form. Ruby is still the majority, I must say, but our service is written in Java. And okay, what are you going to do? You're going to think about how to protect those resources that you're exposing through these HTTP endpoints. And they're going to say the security requirements are going to be, as usual, to do with identity and permissions. So just, I'm sure everybody is fully on board with this, but just to get the domain language out there. So identity means who is the person or entity who is trying to access your resource. And permissions means it's something more fine-grained, and that's all I really need to say at this point. It's something more fine-grained, like, is this user or machine who's trying to access my resource, does it have a particular characteristic, like is it a user? Is it an admin user? Is it a user from the legal department? Those kinds of questions you might want to ask. So how is that data transmitted to the resource servers that need it, and how is it then decoded and interpreted by the resources? So a lot of that is obviously going to be to do with what data do you need to make the decision. If you don't have the data, then you can't make the decision. And then also, crucially, who is managing that data? Is it centralized? Is it distributed? Is it synchronized across multiple backends? Those kinds of questions end up being highly relevant. Okay, so that's kind of the starting point. Now, what could you do about it? Well, the first thing you could try is just bog standard HTTP basic authentication. Really easy to set up. Something of a lowest common denominator, as it says at the top of the slide there. And does anybody actually use Spring Security in this room? I'm expecting quite a lot of people. So, and have you ever used the HTTP basic authentication? Quite a few people. Yeah, I mean, ever used is the key word there. It's everywhere, right? I mean, it's really easy to do. It's pretty much ubiquitous on all client libraries that you would want to use. And for instance, here's my basic sort of prototypical example. Curl, right? I mean, I think you can even run it on Windows. But it's a command line client. Who uses curl, or who has used curl? I don't want to be the only person in the room who knows what curl is. So all I'm doing with curl is I'm using this kind of notation where I do username : password @ and curl just pulls that out of the URL and turns it into a header. I can show you that working, actually. Why don't I do that? I think this is my little terminal. So I should say network connection at the minute is okay. So if I did curl -v, so that'll show you the headers, right? Can anybody see this? I can make it bigger if you can't. Yeah. So if I do curl minus v, let's think, what would be a good example? It doesn't really matter, does it? I can send this to a resource that isn't actually authenticated. So if I was to do my password at cloudfoundry.com/login, and I'm going to throw in a header just because I'm going to be doing this a lot. I want to get used to it. Application JSON, okay. So can you already see what that's going to do? It's going to send a GET request to this login resource at cloudfoundry.com, and it's going to ask for a response in JSON. And it's not found. Brilliant. Okay, that must be because I've misspelled the server name. There we go. Oh, and I've got it back in XML, HTML. Well, that's not very good, is it? Accept. That's kind of screwed up, isn't it? Somebody should have shouted out. Add the accept. There we go. Here we go. And now it's JSON. Okay, so that just means that it's a bit smaller and I can show everything on the same slide. So what have we got? We've got an accept header going out, and we actually, there we go. There's the authorization header. So that's what curl has done. Oops, that's what curl has done with my username and password. It's just stripped it out of there from the command line, turned it into authorization basic, so that tells the server that it's going to be data in a particular format, and the particular format is, I'm sure you probably all know, base64 encoded, these two values separated by a comma. All right. As it turns out, I didn't need that header for that resource because it isn't protected. So I'll just to show you that that's the case, I'll do the same thing again, and I get the same result. Okay, so that's an unprotected resource, and just to save some typing later on, I'm going to just tell you that I've got an alias set up so that jcurl just means do it in JSON. All right, so if you see me typing jcurl, it's not some special secret recipe, it's just an alias for curl, but with -h. Okay, so that's basic. That's really easy, right? Really easy. And I like easy. I like it when I can curl something. That makes me feel good. I can just poke around. And that's actually what is really good about these RESTful, whatever you call them, lightweight services, right? You can poke around in them. You can make them work. You can drive them from as simple a client as, you know, a little Unix terminal like that. And that really is quite useful and powerful. Okay, so what's wrong with that? Well, like I said, it's great, but where do you get the credentials from is usually the problem. So if I'm a client and I need to access that resource, how do I know what the username and password is? So especially for when you've got machine clients, if they're just machines talking to each other, then that can be okay because sharing secrets between machines is actually relatively simple to do. You just, you know, stick it in a config file or something, a database, you know, encrypt it, whatever you want to do. But they both have to share the same secret. So what that means in practice is that it's really going to be small systems because you don't want to be managing, you know, n factorial numbers of secrets. So that's one limitation. The other limitation is, of course, it is username and password, or it's ID and secret, or whatever you want to call it. It's just key value, which means that it can just about cover authentication, and you know, as long as you don't mind it just being username and password. But if you wanted to do something more complicated, multi-factor authentication, which is all the rage these days, if you wanted your users to actually have a, you know, RSA hard token and wait for the little number to change and type that in, then that would be quite difficult with this. And it also only covers authentication, right? There's no information included in that base64 string other than username and password. I can't actually tell you based on that whether the user is an admin user. I have to go to a database and look him up and bring back the information. Well, that's not impossible, but you know, it adds extra complexity and it adds an extra back-end system. More moving parts, more state.
Okay, and state is, it's not. I don't think we can avoid state, but we can try and sort of push it into corners that we control. So, if ideally what we want for our complex system is some more fine-grained information about what this user is, or this agent is, who's trying to access our resource. So what would be very common, for instance, would be something role-based. I've talked about admin users already, normal users, admin users. As long as you can categorize users into at least 2 classes, right, then you can do something there. That's very common. Sometimes it's even available, as a declarative option in the container. If you're a JEE server, then you often provide this kind of thing. So you just need to be able to categorize users, basically. If you can do that, then you can build a system that works like this, and if you're a Spring Security user, you know that there's fairly good first-class support for this kind of thing. Often, of course, the business requirements are more complex than that. You actually need to do ACL computations. You need to know, it's not just the user is in the admin group. It's also he's an admin user in the legal department who has signed 3 times the form that was sent to him last week, no later than Monday, right? There's all sorts of rules that you can come up with which end up in these computations, and you have to be flexible enough to accept, whatever they throw at you, basically. So what can you do? Let's see if we can expand on the situation of the HTTP basic a little bit more. So a very quick series of slides just showing you the key management problem. Okay, so if you have 3 components in your system, they all want to talk to each other. There are 3 legs in this 3-cornered system. There are 3 pairs of IDs and secrets there, right? If each of these components wants to contact each other, the others on behalf of itself, right? Leaving users out of things even. As soon as you go to 4, it's not just a linear increase. That's the only point I'm trying to make, right? So secret management is kind of, it goes beyond config files, basically, once you get to multiple components in a system. So for small systems, it's fine. Larger systems, you kind of need to centralize identity management in some form, even if it's just secrets. So there's quite a powerful argument there, just for the Nsquared growth, basically, of the number of pairs that you've got to manage. For user accounts, it's even worse, because I was just talking about machines talking to each other, not on behalf of users, right? If you've got 1,000 users, then there are 1,000 secrets that each system has to know as well. Okay, so that's an argument in favor of centralizing secret management. But that doesn't get you any more fine-grained information. Something that might get you some more fine-grained information, and this is the first time we've seen the OAuth2 acronym, whatever you want to call it. So one of the good things about OAuth2, which is one of the sort of prime motivators for the way that we use it, is that it's not just about authentication. In fact, it's not about authentication at all. I hope I'll be able to convince you of that later. It's got more information, or it allows you to encode more information into the protocol. So that's one reason for using it. Another reason, I would say, is that it's always good to... I'm no great slavish follower of standards, and I don't think OAuth2 is fantastic in any way. There's been a lot of criticism of it publicly recently, and there's nothing against anything that anybody was saying there. But it's a start, right? It's something that you can point to and say, this is the spec, this is how it's implemented, this is how it should look, and it's implemented by those guys at SpringSource. They've done it for us, so if it's screwed up, then we blame them. And that's always a good thing to have with security, somebody to blame, right? And the other side of that is, especially in the enterprise, and actually, ironically, the criticism that has been bandied around recently about OAuth2 from the former spec lead was actually along the lines of it's too enterprisey. In other words, it's too useful. So the more people say things like that, the more I think that actually I should be using it, in fact. And here's a story, right? So I've been consulting with clients on this topic for a relatively short time, only a couple of years, I suppose, or even a bit less. But they often say the same thing, right? I mean, they're struggling to find a solution to this problem. They've got distributed systems with lots of lightweight HTTP. They want something that matches that. And a lot of them, because the standards haven't settled down properly yet, have gone off and sort of crafted something together. They've made something work. But now they're getting pressure from their internal auditors and managers and compliance people saying, why don't you use something standard that we can understand? So a standard is something you can point to, and you can use that. You can use that to justify your usage of it, basically. And I think that's probably, however hard you want to criticize a standard like OAuth2, it's always a starting point, right? It's a straw man at least. Okay, and of course, as I've said, I'm a big fan of curl, so anything that I can curl, I like. And anything that I can test with HTTP, I like, because although HTTPS is absolutely vital, critical in production, for testing, it's just too much hassle to set up, basically. It's not lightweight enough. I don't want to have to manage full certificates, and I don't want to have to switch off certificate checking just to do my tests. Okay, so anybody actually used OAuth2 as a client or a server? I expect a few people have, right? But the rest either don't want to tell me or they haven't used it. So we're going to do a quick introduction. We're going to see some of the vocabulary that's used. I'm not going to cover the whole spec, chapter and verse. I'm just going to give you a taste. Basically, a couple of key use cases, the ones that you'll encounter most often, and maybe demo it a little bit and show you how it's been implemented in Spring. So the little quote at the top is a paraphrase, basically, paraphrase of the whole idea behind it all. So you have a client application, which is often but not always a web application, right, which acts on behalf of, but not always on behalf of, a user, but with the user's approval. So the user knows that this is happening, but the client application is accessing a resource, a protected resource, as if it was the user. That's kind of the core use case, if you like. Now there are other ways of using OAuth2, but that's kind of the primary use case that I want to get to, and it's also the most complicated, and it's the one that most people use. And so there are actually probably more than 3 participants in that, but the 3 key ones that we want to talk about are an authorization server. So there's a centralized server that grants tokens to enable this interaction, and the interaction is actually between the client application and the resource server. So the resource server is this lightweight service, which is, for instance, the cloud controller in Cloud Foundry. So the cloud controller is a lightweight JSON-based HTTP service. You send it. I'll tell you what, I can do you a quick demo. You send it. Cloud controller is not UAA. The cloud controller is api.cloudfoundry.com. So if I ask it for info, it tells me about itself. Okay, so that's an example of a lightweight service that has been used in many web applications, right? So a client application that was calling this would be an OAuth2 client. In that case, it wasn't a protected resource, so I didn't need to. I'll show you how to access a protected resource in a second when I've been through this slide. So that's the resource server. The client application should not be confused with what you might think of as a client, which is usually a user. The user is the 4th participant in the flow here. The user is known as a resource owner in OAuth2 domain language. I'm probably just going to call it a user. Okay, so it's becoming more common on the net. So it's a standard. OAuth2 was started by the Facebook, Google social crowd, basically. So that's why the fact that it's becoming useful as an internal enterprise tool is a little bit off-putting to some of the original spec leads. But so Facebook is there with its Graph API. Anybody used it? Couple, yeah. It's quite common these days, right, to see that button on the screen of your third-party app. It says login with Facebook. You probably, if anybody of you joined that Greenhouse thing, the site that reflects this conference, there's a Twitter link on that. Twitter actually isn't OAuth2, but you get the picture. It's the same kind of thing. Google APIs, I think they're all protected with OAuth2 now. There was a transition phase when they moved from being something else. And as a third example, I'm giving you Cloud Foundry, which has a load of resources which are protected using OAuth2. And so the common pattern you see when you do this is you log in, the application you're visiting might be, I don't know, somebody's photo viewing site, right? That's the poster child. And it says log in with Facebook. So you click on the button, and what it doesn't do is collect your Facebook password, right? You don't give your Facebook password to anybody except Facebook, hopefully, right? This is a lesson that everybody should learn if they haven't already, but that's the whole point. You don't give your Facebook password to anybody but Facebook. So what the third-party application has to do when you click on that button is it has to send the browser a redirect to Facebook, so Facebook can collect your login credentials. Or maybe not, because probably you were already signed in with Facebook if you use it a lot. So what's that? That's a single sign-on. Lots of applications can be using Facebook as a single sign-on server. And okay, that's probably not a highly trusted source of authentication, but if you're just, collecting social data about people, then that's probably good enough. So Cloud Foundry, Google, they do the same thing. If you have a client application, third-party client application, or even second-party, or even first-party, right? So for example, the support site for Cloud Foundry, if you go to support.cloudfoundry.com, why don't I do that? Oh, actually, this is a browser, isn't it? There we go. Let me go to support.cloudfoundry.com. Am I logged in? It doesn't say I am. Okay, so it says login. That will take me to login.cloudfoundry.com. See that? And I can put in my Cloud Foundry credentials, username, password. I could do that just for the sake of argument, but it doesn't show you anything very spectacular, except that I can remember my password, if I can remember my password, that is. Looking good. There we go. Right, so now I'm logged in, DSire. So what's just happened there was I was redirected to login.cloudfoundry.com, which is the authorization server. It's the UAA, which I haven't introduced formally yet. Who's making that noise? Is it me? Might be my phone, if it's right next to the thingy. Yes, could have been. Okay, so I've now got an authentication, a cookie. My browser has a cookie with Cloud Foundry, which means I've got a single sign-on, basically. Anything else that wants to use that login.cloudfoundry.com, I won't have to do that again. So that's what single sign-on is, right? Okay, so back to the slides. There's a picture of it. That's what just happened, right? So I had a user, that was me, my browser, Firefox, went to the client application and wanted to access a private protected resource. The client sent me a redirect to the authorization server, which is the green one, auth. I'm not doing anything with that. I authenticated with him, and he sent me another redirect back to myself, back to the original client. And in that redirect, although we didn't see the request, that we didn't see the whole conversation, in that redirect was an authorization code, a one-time, one-use token that I can, as a client application, I can exchange. That's what this little back channel is here. I can exchange that one-time code for
an access token. An access token can then be used to contact a resource server, and the access token contains information about me, the user. So that's the chain of events. I'm going to show you that in a bit more detail as we go through it. So there's the sort of equivalent of the first command line client that I showed you for basic authentication. This is the OAuth2 curl. So it's sending authorization bearer instead of basic. And instead of username password, it's sending an access token. And the access token is a string. Okay, it's basically, as far as the client's concerned, it's opaque. It's just something that it got from the authorization server. And that allows me to access this resource, which is protected. All right, so that's on the resource server. This is a bearer token. It's called a bearer token because if I bear it, if I have it, then I can claim to represent the user. So that's what the client's doing. He's presenting the bearer token, saying, I have this token, therefore I have permission to operate this resource on behalf of the user. You have two questions here.
Will the resource server then call back the authorization server to validate the token?
So the question is, will the resource server call back to the authorization server to validate the token? The answer is maybe. It depends on the implementation of the resource server. And on the sensitivity of the data, probably, right? So one reason I can think of why it would call back to the authorization server would be because the token might have been revoked, right? Somebody might have decided that that token is bad and somebody's stolen it, so they want to revoke it.
Or the token has a timeout.
Or if the token has a timeout, he says, yeah. So the token might have a timeout. The resource server can interpret that token any way it wants, but it should respect the information in it. So I'll show you some examples where connecting to the authorization server will be one way of doing that, all right, but not the only way. Another way would be to contact some shared storage, which they both understand. The resource server and the authorization server both understand the data that's stored in a database. And a third way of doing it would be to encode data in the token itself. And I'm going to show you some examples of that because that's what we actually do in Cloud Foundry. The disadvantage of doing that is the token revocation becomes a problem because resource servers don't check. Every time they get a token, they don't check if it's valid. They just look what's in it. They can tell if it's expired or not by what's in it, but they can't tell if it's been revoked by a subsequent user or administrative action. So that's why it depends, because if you're sensitive about things, you might want to contact the authorization server at least occasionally. Or you might want to do something like only issue one-time tokens. So you can only use this token once, therefore if it's been used before, you can't use it again. How would you know? You have to contact some shared storage, or somebody has to keep track of which tokens have been used. So, all of these concerns are relevant and valid, but are not defined by the spec. You can implement it however you want, right? It's just actually I'm going to have some slides in a minute about the responsibilities of all the participants in this flow, and then you'll see, I think, more clearly what is and what isn't mandatory. Yeah, there was another question. How does the resource server know what is the username? It might not care. I'll show you some examples where it does. Okay, so I'll show you what we're doing in Cloud Foundry because the cloud controller does want to know the user's ID when it gets a token. But I mean, as far as the resource server is concerned, it might only need to know that there is a user behind this request. It might not need to know which user, right? So it depends whether it needs to know or not. But if it does need to know, the answer is the same. It either has to contact some back-end storage or the authorization server, or look in the token itself and decode it. So typically, the token is opaque. If you're a client, you're not supposed to be able to decode it. If you're a resource server, you are supposed to be able to decode it. It's just how you decode it is not specified by the spec, so you can do it any way you want. Does that make sense? Sorry. So this command is for both authentication and authorization. Yeah, if you use the term authorization in the sort of traditional Spring security sense, because it would contain enough information to make both decisions. Yes. Okay, that's good. That's good.
ask questions, feel free. It might mean that I do less demos, but that's probably fine because it gets us talking.
One question.
Yeah, another one.
Is it using some type of token key of the site connected to the token, or how it is sure that only the server can?
I didn't quite hear the beginning of the question. Is it using...
I mean, how does the server and the authenticator share the secret which is necessary to understand the token?
Right, okay, so how does the resource server and the authorization server, I think if I use the terms correctly, how do they make sure that they're looking at the same information? Yeah.
One of them encrypts it, the other one needs to look at it.
For instance, right. So for instance, the authorization server might have encrypted the data in the token. If the token contains data, it might not, right? It might just be a random string. But if the token contains data, then I recommend that it is at least signed, right? So that the resource server can check the signature and make sure that it came from the authorization server. And in Cloud Foundry, we use public-private asymmetric keys for that. So the resource server goes, here's a token. I know how to decode that. I'll just strip all the data out of it. Actually, I'll show you. So, okay, if you're a Cloud Foundry user, you've seen VMC, right? If I do, let's see, make sure I've got the right Ruby involved. VMC info. So that was a round trip to the cloud controller for an unprotected resource. And I can see that I'm signed in as CFID VMware.com, right? So that's what the cloud controller told me that. Actually, it was an authenticated request in that case, wasn't it? So what was I going to do? So in that case, what I know is if I do cat VMC token, that's where VMC stores its access tokens locally so that it can, it doesn't have to go back to the UAA every time it needs a new token. And in that, this is just a JSON object, and there's my Cloud Foundry API endpoint, and here's the bearer token. There's a Cloud Foundry access token. It's an OAuth2 bearer token. And if you look at it, it's apparently random strings, but it looks a lot like it's base 64 encoded, doesn't it? Yeah, it is. You can also see some periods. There's a period, one period there, and all the way nearly to the end, probably somewhere there. There it is. Yeah, you're right there. Okay. So it's a JWT, right? It's a JavaScript web token or whatever they call it. You can decode it, right? So you can decode it really simply. Let's see, I've probably got an example. So if I do token equals that, right? Then I've probably got somewhere, if I echo $token, somebody tell me if I'm doing something really stupid here. Cut minus D is delimiter, right? Delimiter period. Second field is the middle one. And then I can do base 64 minus decode. There, that's the contents of the token. So anybody can decode it, actually. We didn't encrypt it. We could have encrypted it if we were super worried about people doing this, but we're not, because there isn't anything very useful there, right? I mean, I've already signed in, so I know who I am, and it's just telling me who I am again. If I was the resource server, though, I'd want to be a bit more careful, right? So there's something else there, which is the other two fields. So there's a signature, right? So the resource server checks the signature and says, where did this come from? Did it come from where it says it came from? Which is the UAA, and I can do that by exchanging secret information with it, basically. And actually what we do in this case is a public key. So the UAA publishes a public key. It's not in production yet, so it's still a secret key in production, so I'm not going to show you that. But I could, when the next, there's a 1.3 release of UAA coming out soon, and we're going to start publishing the public key instead, because the cloud controller should be using that. It isn't at the minute. But what you can see is another thing here which is relevant to the resource server. There's an audience field, so that's just part of the JWT
token standard. So that says the audience for this token is a resource called OpenID, or a resource called Cloud Controller, or a resource called Password. So if I'm any of those three things, OpenID is the thing that lets me do a single sign-on. So that's just a get me the current user details resource. Cloud Controller is the Cloud Controller. That's the api.cloudfoundry.com. And so if I was a Cloud Controller, I would accept this token, which is what I did, really, when I did that, right? When I did VMC info, what happened was it sent, I think you can do ---- trace equals debug, and you can see the headers. Let's see. There's the JSON response. And does it print the headers? Let's see, no, it doesn't. Just the response headers. So the request header, there was an authorization header. I could prove it with TCP dump, but I don't want to get distracted. So yeah, I mean, a lot of these details to do with encryption and signing and all that stuff is implementation dependent, right? So this is a UAA token that I'm showing you. So let's get back to the slides. Here's the first of the role slides. If you're a client application, this is what you must and should do. All right. First of all, you have to register with the authorization server, because it's going to give you a client ID and a secret, which is going to enable you to get that token. All right. VMC is a client of the UAA. It has an ID called VMC. It doesn't have a secret, for reasons that I'll go into later. Rule number one, you must not collect user credentials, and that's one of the things that we'll be going on the warpath about pretty soon, and trying to make sure that there are no Cloud Foundry apps collecting user credentials, because they shouldn't need to. They should redirect and get the UAA to do that. They can then, if they have these things, this client secret and ID, then they can obtain that token on that back channel. And when they do that, they use HTTP basic authentication. They use that ID and secret. So there is still a role for basic authentication here. In order to get an access token, the client has to authenticate. So the client can either obtain a token on its own behalf, which is called a client credentials grant, or it can obtain a token on behalf of a user, which is what most of the examples are going to be about, and then use it to access a resource. So that's what client applications do. Quick digression about client credentials tokens. So if you had a client registered with a server, my client, my secret, at uaa.cloudfoundry.com, that won't work, by the way, don't try this. If you say -d grant type, so -d is curl form parameters, so this is going to send a form body in the request. Grant type equals client credentials, tell it what the client ID is, and it'll send you back an access token. And a short form of that, so it's not as long as the one that I showed you because I couldn't fit it on the slide, but this is what you get back in JSON. You get the value of the access token, you get an expiry time, expiry estimate, it tells you how many seconds it'll last, and it tells you what the scope, and that's actually the first clue to what the additional detailed information is going to be in this token. It tells you what I can use this token for. I can use it for admin tasks at the UAA. More on that later. Which part is the signature? To be honest, I can't remember. I think this part tells you just about how the signature is created, and I think it's the bit at the end, because that's the most variable. If you look at a bunch of tokens, you can see which parts vary the most, and it's basically this bit at the end. I think that's the signature. I don't remember, because I just use a library to encode and decode them, right? The library, incidentally, the library for that is Spring Security JWT, so it's from the family of Spring Security crypto jar, codec jars, so it's just a tiny jar that just does JWT, encrypt and decrypt, encode, decode, and it lives in the Spring Security OAuth2 project, so we've built it there and deployed it to Maven there, so it's officially still a milestone release, but it will get to 1.0 pretty soon, because it hasn't changed its features. Okay, so what are the key features of what we've been looking at? We've now got a flavor, I think, for OAuth2. Mainly from the client side, so I'm going to start showing servers hopefully before we get to the end of this presentation. Key features for clients, extremely simple. Great, I can just put a bearer token in a header and I can do anything with it. Extremely key feature, the access tokens carry information beyond just the identity. It might not even be the identity, but you can basically overload as much information as you want into that token just by encoding it in the token itself or using a token as a key to some shared storage or whatever you want. So those are the questions I answered earlier. Examples, and so the resource servers basically can do what they want with the tokens, and things you might want to put in there are the client ID, the audience that we looked at briefly there, the resource ID. The user ID might go in there because the resource might want to make a decision based on the user, and maybe some role assignments. And role assignments are easy for everybody to understand and encode. But you could add more, right? That's the point of that. It can be anything you want. The spec doesn't say what's in the token. It just says it's opaque to the client. Yes?
So it seems like the resource servers and the authorization server kind of have some how to read that token.
Right, okay. So the question is, or the comment, I guess, first was there are some dependencies now between the resource server and the authorization server. They need to sort of agree on some terms of reference. And what does that mean for the client, exactly? Well, again, I mean, that's left completely open by the spec, but HTTP and, driven by this inspiration that we've had to do RESTful services, the client will know if he can use the token by trying it because he's going to get a 403 forbidden if he was, in the right ballpark, and 400 or 401 depending on what the resource server thinks. But the client's going to know pretty quickly what he can and can't do just by normal HTTP protocol, basically. That's kind of a good way to think about the problem. The resource server and the authorization server do end up sort of a little bit tightly coupled, because they have to agree on the, what the resource server is expecting to be in the token is going to be in the token. So it's not terribly useful, therefore, to have random, completely unrelated to Cloud Foundry resources deployed, because they sort of need to communicate at least what their expectations of the token contents are with the cloud control, with the authorization server. So there's a little bit of tight coupling there, in a good sense. And the fact that the client has to register with the authorization server also introduces a relationship that you could try and avoid, but you probably don't want to, because you want to have some shared secrets just to protect the whole thing. Another follow-up. Okay, so it's a discovery question. Is there a way for a client to know, for this resource, I need to go to that authorization server? Actually, there's nothing in the spec that tells you that, but if you look at this, that was my info call. Look, the cloud controller is telling me where I can get a token. So that's a really simple resource-driven discovery protocol that we invented. But it seems pretty sensible to me. If the resource server knows if it knows how to unsign and decode the tokens, then it must know where they're going to come from. So that seems like a sensible step to me. But there's nothing in the spec that will force you to do that. Okay, so bearer tokens. We've talked about all these points now. They're opaque to clients. They can carry very important information to resource servers. And here's an example of a UAA token, which has these audience fields that tells the resource server who it should be. It has information about the user, a name and a user ID. It also has the email, because that's traditionally what users
identifiers in Cloud Foundry, but it's duplicate information. Was there a question?
Yeah, it's kind of maybe on the previous discussion. So the resource, the client application goes to the authorization server to get the information about the user. How are the end users set up in the authorization server, and how are their roles and permissions assigned?
Okay, observation, just repeating the question, observation, the client goes to the authorization server to get information about the user, sort of. It gets the token, it doesn't actually know if it's got information about the user. Where is the user data, role-based data, whatever it is, stored? Again, it doesn't matter, but for the sake of argument, in the case of the UAA, we have a back-end database that we use to store the information that we need to run Cloud Foundry. Right. I'm going to talk a little bit later in this presentation about externalizing that stuff and separate authentication processes and stuff like that. So if you're thinking enterprise, I want to reuse my existing user store, then that's a good thought to hold on to, and we'll come to that. Yes. So is the authorization server an identity manager? Yes. Up to this point in the picture, it is, yes. And so there are ways to pick that apart a bit. Actually, the important point that will come later is the authorization server is an authorization server. It doesn't have to be an identity manager, but it is in the case of Cloud Foundry. Yes?
Do you know if popular products now in the industry support OAuth2?
Do popular products in the industry support OAuth2 on the client side? As the authorization server. Oh, I see, right. So enterprise products, yeah. No, I mean, the OAuth2 is extremely popular in the sort of webby, socially space. So there are lots of libraries, client-side libraries that allow you to integrate with it. And they usually have, a Google implementation and a Facebook implementation and maybe a Cloud Foundry implementation, because the protocol implementations are all a little bit different because of the spec changing so much, and also because, well, the endpoints change, right? And Google has a different authorization server than Facebook for a good reason. So there are plenty of products out there, but I don't know of any that are sort of from the traditional security vendors. I'm sure that there are people at RSA and Computer Associates who are completely on board with all this stuff, but they don't so far show up in the enterprise landscape, in my experience. I could be wrong. Anybody seen anything coming from that direction? Actually, MITRE. I don't know, does anybody hear from MITRE? Yeah, brilliant. Okay, so I know you guys are working on some cool stuff that might just be internal at the minute. I don't know, but there's that's a fairly sound, secure enterprise player, and they're using OAuth heavily. So I can think of examples. And they'll probably be using Spring Security or OmniAuth on the Ruby side, or even Spring Social. There are client libraries that support this kind of thing. I haven't really got time to talk about that in much detail, though. In fact, I'm running out of time here completely. I've got to move on. Okay, so there's that picture again. Now we're going to get to this splitting up the identity manager and the authorization server. So that's what we've already seen. The client and the browser both contact the authorization server itself, and that's both the authentication data source and also the token granter. And also, incidentally, in the case of the UAA, serves several interesting resources like user info for single sign-on. And that's the sequence diagram of what happened. I described it before, so I don't want to go through it blow by blow again, but there's a redirect in a couple of places here, right? User gets a look at some authorized, so it tries to get a resource on the client. The client says, no, you can't do that yet because I haven't got a token. Go and get a token. The authorization server makes sure he gets approval for that token grant. You didn't see that when I did it with the sign-on, the support sign-on for Cloud Foundry, because we don't think that users need to approve that. If they're signing on to Cloud Foundry, they must be approving it. But you'll see that when you log into Facebook third-party products a lot. Then the back channel bit. Okay, so it goes back and it gets this code. This is the authorization code I was talking about. Hands that back to the client. The client uses that in a back channel to get the access token, and then uses the access token to get the response. Okay. So that's that in words. The authorization server in this picture is authenticating the user and issuing authorization codes and access tokens. Yeah, Chris. I don't take questions from you. How does the user know he's been redirected to the authorization server? Well, yeah, so it's obviously prone to the usual sort of spoofing attacks, like if you put the Unicode character that looks like an O in place of the O in Cloud Foundry, you can probably set up a fake domain that looks like the UAA in Cloud Foundry. But, I mean, that problem isn't solved anywhere else, so that's still there. But basically, you have to teach your users to only give their credentials to login.cloudfoundry.com or the login page on facebook.com or whatever. It's a user education problem. And also, because the authorization server controls the registration of clients, if it thinks that a client is misbehaving, it can strike it off, and it can also check when it's registered that it's got a valid, return callback URL, that kind of thing. So there are some checks and balances in the system, but it's not completely impervious to spoofing attacks, but because no single sign-on system is really. Okay, here's another role slide. The role of the resource servers, as we should have seen by now, is to extract the token and decode it in some way. It doesn't need. You don't need to. The spec doesn't say how you do that, but you can do it in various different ways. And then it makes an access control decision. And the way it does that is it looks at the scope of the token, and the scope can therefore contain interesting granular information. It looks at the audience, recommended but not mandatory. Perhaps it looks at user account information. Perhaps it looks at information about the client. Whatever is in the token it can use, right? If it thinks that it can't meet the criteria, then it just sends 403, and the client can work out how to deal with that.
In that case, how will it know that the token is not sufficient? It will be calling back the authorization server to check that, right?
It shouldn't. Okay, so how will it know? Does it have to call the authorization server to know that it's sufficient? It shouldn't, because the resource server is a resource serving. It should have its own security rules, right? The authorization server is just giving it data in the token, basically. How it interprets it is entirely it's a business decision for the resource server. So there's a little bit of, like the question over there, there's a little bit of cooperation has to go on, so they have to sort of agree on the terms that the language that they're going to speak. But for instance, the scope, we're going to have a slide on scopes now, I'm sure, soon. Okay, and scopes are arbitrary strings. The third role slide, okay, what does the authorization server do? It grants tokens, we've seen that. It often does provide some sort of RESTful interface for users to verify who they are, or for clients to actually verify who the user is, what the user's name is, email address, that kind of thing. The stuff that you can get from the Facebook/me or whatever it's called, right? That kind of thing. It also has to occasionally authenticate users, so if the user wants to go to the authorized endpoint and get one of those codes, then he has to prove to the authorization server who he is, okay? The spec, of course, doesn't tell you how to do that. That's good. It also doesn't tell you how to do that, or whether even that it should do that. It does tell you that it should grant tokens and it should authenticate clients when they ask for tokens. The other two things are left up to implementation, which is good. Okay, so now client registration and scopes. Registration is kind of one of these safeguards against abuse of the system, basically. So OpenID, for instance, as in OpenID 2, like Google uses, for instance, for a lot of click on to sign on Google, that's a really open protocol. It allows you to authenticate with Google without having any
previous relationship with Google. OAuth2 isn't like that. You have to have a client ID and secret. You have to do something to identify yourself to the authorization server. And one of the key things you have to do is register a redirect URI. Actually, it's not mandatory. The spec doesn't say you have to, but a sensible authorization server will enforce this, so that when the authorization server sends the auth code back to the client, it does it through a redirect, and that's registered. That endpoint is registered, or it's a substring of it is registered. That's what we do in the UAA. So you can register, the host and the app ID basically, but you can call back to anywhere inside your own domain. And there will be some allowed scopes, and all clients are not equal. Some clients can do admin tasks on behalf of users, and some can't. That seems perfectly sensible, right? So the authorization server has to decide how to limit that, and that's, of course, left open to the implementation, which is one reason why we haven't got very many registered clients in Cloud Foundry, because we're a bit cautious about giving out credentials. Okay, and also useful stuff that you might want to have is a way to identify which resources you can access. So that's answering a question over there. It's not mandatory, but it could be included in the client registration. And also, maybe if it was a user who was registering the client, you might want to remember who that was so that you can contact them if you're removing their access, for instance. Okay, more on scopes. They're arbitrary strings. There's just something that you agree between the authorization server and the resource server. In the case of Google, they've got this URL format. So if you want to see user info, you have to ask for this kind of scope explicitly when you get the authorization code. Facebook uses sort of role type, resource name type short strings, very mnemonic, easy to read. The UAA uses some of those, so it uses OpenID, for instance, because that actually comes from OpenID Connect. It's an OAuth2 authentication spec protocol. The internal scopes that it uses are period separated, so they're actually encoding the resource that it's intended to be accessing. The cloud controller, in this case, cloudcontroller.read, means that you can, if you have a token with this scope, then you can, read information from the cloud controller but not write it. You can look at your apps, but you can't deploy a new one. But that's a naming convention that we came up with. It's useful for us, but it doesn't have to be that way. So UAA scopes are actually also stored, and there's a question over here about that. In our database, we store them as groups, and we implement another standard called SCIM, Simple Cloud Identity Management, which is these two endpoints, basically /groups and /users. So if you looked at a user, here's a user from the demo server that I would have been using if I'd had if I'd been doing more demos, and you can see groups there. So each group has a display name which has got the scope name in it, basically. So we store that information. It's a bit like roles. A group is a bit like a role, right? You could make a one-to-one association there, except that we also have this period separator naming convention, so we put the resource ID in it as well. Special mention for VMC, because there's a special authentication protocol for VMC. Again, the spec doesn't say how you should authenticate clients, so we can do it any way we want. This is how, if you were VMC, this is what you would be doing in curl terms. You would be sending a request to the authorized endpoint. You would be asking for response type equals token, which would tell the UAA that you wanted this kind of response. You want a 302 with an access token in a fragment, and that's called the implicit grant flow in the OAuth2 spec. The secret UAA stuff here is this authentication protocol. So this is saying if you include source equals credentials, that precise string in your form parameters, then we expect to see username password as well. And if you do that, then you can be VMC. So I would demo that if I had time, but I think I'm running out of it. So I'm going to jump on. So I could curl that, and you could see a token coming back from the UAA, and that would prove that that's what VMC was doing, sort of. Okay, now the splitting up of the identity piece. So authentication.
i.e. checking who a user is, who they say they are, is actually completely orthogonal to the token granting features of the authorization server. The authorization server has to grant tokens, and it has to identify a user and get their approval for the grant, but the spec doesn't say how to do those two things. It just says it has to happen. So that's great, because it leaves this completely open if you want to. So they don't, in other words, authentication and authorization or token granting can be completely separate components, and that's what we've chosen to do in Cloud Foundry. So authentication is then deferred to an existing enterprise perhaps system for single sign-on, and all the authorization server has to do is trust that source of identity information, and that's easy to arrange in various ways. We do it with OAuth2 authentication actually, but you could do it with, for the sake of argument, SAML assertions or Kerberos or whatever trusted channels you had between the authorization server and your identity manager. Okay, so the main thing is, apart from a special case of a password grant, which is defined in the spec but isn't actually, frankly, that useful because it's pretty limiting. So you're allowed to get a token as a user directly, effectively, so you can collect a user's password and then send it to the token endpoint, and you'll get that if the client is allowed to do that. But we don't allow any clients to do that in the UAA, for instance. The point is, it doesn't have to be done by the authorization server. So you can take that picture, which has got the UAA as the authorization and authentication source, and replace it with that, effectively, which is saying that now the login server, which is the server you saw when I logged into the support site at Cloud Foundry, login.cloudfoundry.com, is the source of identity, basically, authentication. So he makes sure he knows who you are. He actually also delegates, he provides the UI for approval, user approval. So there's a page that comes up that says, actually, why don't I do that? I think I've got time to do this, just to prove that it's working. So instead of cloudfoundry.support, I've got a server running in the background, which is the UAA, with some demo stuff. So if I go to localhost 8080 app, then I get redirected to UAA login, and because it's a demo system, I can tell you that the username and password is Marissa Koala. That's the approval page, right? So it says, you've seen this with Facebook probably. If you get a third-party app trying to authenticate you with Facebook, it comes back and says, Facebook tells you this app wants to use your data. Do you think that's all right? This app wants to write on your wall. No, thank you. So this is what this app wants to do. He wants to access your personal data. He wants to change your password. Not so sure about that then. So you should read this, right? This is a message from the authorization server saying this is what this client wants to be able to do. Do you authorize that? If so, then I'll give him a token. If not, not, right? So those two pages that we just saw, those two pages that we just saw in the in Cloud Foundry actually live in the login server. And as things stand today, the login server and the UAA are one and the same. They're just routes to the same server. But probably starting in about a week or two, because we've got the technology already deployed to do it, the login server and the UAA will become different. And then you've got the login server, which is the UI, and we can brand it any way we want. And we've got the UAA, which is, I'm basically positioning it towards the end of this talk as a general purpose authorization server. If you want to see an OAuth2 authorization server, use the UAA. It's got lots of nice features. Spring Security provides most of them, but we're opinionated, so we've made some choices there, and if you want to make similar choices, then the UAA is a really good starting point. So we don't really want that to be branded. We want you to be able to do that yourselves, right? So the way to brand it and the way to hook it up to other identity stores like LDAP enterprise directories or SAML identity managers would be through this kind of pattern. And that's what we've done. Anybody here from EMCC? EMC is our parent company, as you might know. They have a consulting
and they've been looking at the UAA as an identity management solution for one of their projects. I think it's an internal one, but it looks quite interesting, and that's a SAML identity manager, an existing one. Okay, they already had that. They don't want to throw that away. It's got lots of useful information in it. They want to use that as the identity source of authentication, basically, but then the UAA can grant tokens, and then the tokens can be used in the internal system. So the fourth and final role slide, what's the login server doing? It's authenticating and maintaining SSO state, which is at the minute just a session cookie, but it could be more than that. It's branding a UI, and it also actually provides the OAuth2 endpoints, and what it does with those is it just passes the calls on directly to the UAA and just passes the information back. And it does that through a trusted channel to the UAA. So what the login server is basically saying to the UAA, I am the login server, this user just authenticated, here's his username. If you recognize that username, you can grant a token, trust me, he's okay, because he's authenticated it, and there's only one way for that message to get to the UAA. It goes through this channel, which is protected with OAuth2, actually. Okay, so the UAA is a relatively good general purpose solution. What does it do in addition to Spring Security? It's got some user account back-end storage if you want to use that. It's open source, Apache licensed, fairly generic but opinionated. Some good sample apps. So the sample app I just showed you is in the GitHub repository. It's basically a fairly thin wrapper in the OAuth2 provider space. It's a fairly thin wrapper for Spring Security OAuth. So let me just show you quickly how that works. So if I looked at the OAuth endpoints configuration in the UAA, this is what it looks like. Spring configuration file. I like XML. Apologies to those who don't, but that's how you do it, basically. That's an authorization server. So it's an XML DSL from Spring Security OAuth. So if you wanted to, you could just use that. And then what you'd have to add on top of that is user account information and provisioning and getting the data that you need to do the identification piece. But that's all you need to grant tokens, basically. So I can do authorization codes, implicit grants for a VMC. I can do refresh tokens, which we haven't covered, client credentials, and I can do passwords, but we don't actually register clients for that, except one, which slipped under the radar somehow. Anyway, so it's Spring Security, so it runs in a servlet container. We run it in Tomcat. So most people in this room, if you've used Spring Security, will basically find it easy to understand. You can pick it up and play with it, customize it, rebrand it, whatever you want. There have been a couple of blogs out recently by me on the blog.cloudfoundry.org site. I showed you one. There are actually 2 or 3 in the last month or so. There's going to be more. I'm going to do one next week, I think, on how to be a client application. Even though we don't have a client registration protocol, we need to get the message out there so that people don't start collecting client credentials. Okay, so here's some more detail about, basically, I don't want to read the slide. It's the choices that we've made that are not made explicitly by Spring Security. So the UAA provides opinions, basically, about how some things should be done, and these are they. For instance, providing a user info endpoint so that you can do single sign-on. Seems like a reasonable thing to do, but it's not in this OAuth2 spec, so it's not really in the framework. Other resources we provide, in addition to the OAuth endpoints, we've got user info for OpenID Connect. We've got token decoding. If you wanted to do that token decoding thing that we were talking about over here, you could do it with the UAA. So the Cloud Controller doesn't do that because the Cloud Controller is really fussy about doing HTTP requests. Basically, the guys who write it don't like doing it, so they want to decode the token. They don't want to contact the UAA at all if they can avoid it. There's a login endpoint which tells you basically how to log in. It tells you that you can use a username and password, and you can send it to this endpoint. And we provide these important users and groups endpoints, so the SCIM account management things, password changes, token management, so you can revoke tokens,
Client registration is provided through RESTful API as well. These are the scopes you need. There's a password strength meter. So if anybody, does anybody seen the Dropbox password strength meter? If you type in your password in Dropbox, it gives you a little red or green arrow thing. We basically implemented the same algorithm. And you can get that through /password. I think there's a blog coming out about that next week as well, or very soon anyway. And there's some management data. That's actually quite interesting for Java people. No, I'll just describe it. Okay, so /health_z, it should say, is something that the platform uses. It just pings the server. It's an unauthenticated endpoint. If it gets anything back, then it's happy. It knows it's healthy. So we just send back OK in the body. And /varz is used for basically management information. So varz is what we've done in the UAA is we've introspected mbeans. So we send back anything which is an mbean. You can see through the varz endpoint. So that means you can get your data source, data pool, connection pool information. You can get your thread pool information. You can get your Java heap size. All this the stuff that you would want to know if you were wondering about how the system was behaving in production, and we use that for monitoring the system in production. Okay, quickly before I finish, and I want to leave a bit of time for questions and a demo if anybody wants me to show the internals of the UAA a bit more, I will. I should at least mention that there are alternatives, right? OAuth2 isn't perfect. It does have warts. I might not use it for everything, but I think it's quite good for the things that we're using it for. OAuth1 obviously was there before, and a lot of people are still using that. It's a lot more complicated to operate, especially as a user, because there's a lot more signing and encryption going on. It's mandatory, and you have to be really careful, and you can be really confused by the errors that you get. So I'd say it's probably legacy at this point, so I kind of wouldn't use it for that reason, but it is, it's a reasonable stab at a protocol that has a couple of features that OAuth2 doesn't have, in the vanilla version at least. There's always SAML, right? That's been around forever. WS*, anybody? So I was rightly criticized last year for speaking about SAML in a negative way. I don't want to repeat that mistake. You can do everything that I've described about OAuth2 with a SAML identity manager, of course. SAML starts from a sort of more, a different set of assumptions, but you could get to the same point if you wanted to. The difference would be that you would be sending a lot more data, right? I mean, the SAML headers that you send are typically bigger than any of the access tokens that I'm using. And it's much harder to set up and get yourself up and running. I'm sorry, I couldn't avoid it. He said that sounded negative. Or you could do it yourself, right? You could roll your own, a custom solution. I've seen it in several places where I've been visiting in the last year or two, I said. I went to a really interesting talk by Rob Harrop last week. Anybody know Rob? One of the SpringSource founders. So he left VMware actually this time last year. He's now the CTO of a little micro-lending company. And so, they've got a sensible modern architecture with lots of RESTful services and all talking to each other. He tried OAuth2 and for various reasons decided to discard it. I won't go into that. And what he's done instead is he's doing a custom request signing algorithm, basically. So it's homegrown. It's completely simple, completely watertight. Almost nothing can go wrong. It's good. It pleases him. It doesn't have some of the features of OAuth2, but he didn't need them. And it's arguably more secure than the vanilla bearer tokens that we're using, because you've got non-repudiation and no repeats and all sorts of other guarantees built in, which you could add, incidentally, which is the last point, right? Extensions to OAuth2. There's lots that the spec leaves out intentionally because it's implementation dependent. So if you wanted to start encrypting tokens, you could. If you wanted to start signing requests, you could. If you wanted to use SAML assertions instead of authorization codes, you could. Right? There's nothing stopping you from ratcheting up the complexity, if you like, but also the protection against certain vulnerabilities. You can increase that. We've chosen not to with the UAA, and most OAuth2 providers don't, because, well, think of it this way. It's a bearer token, it's in a header, so anybody who steals it can represent the user, right? That's the fact. You can be me if you get my access token. How bad is that? Well, I mean, was anybody in Rob Winch's talk, just like Spring Security talk just after lunch? Somebody asked him about this basically, and he said, well, if you don't use HTTPS, you're dead anyway, right? Because even if you're just using a cookie, somebody can steal the cookie and that represents the user. So bearer tokens are no worse than cookies. In fact, they're better than cookies because you can cancel them. You've got some control over the data. You can expose that quite easily. So there are some alternatives. It probably is a good starting point, though, I think, OAuth2. I like the simplicity. I like the fact that, especially with something like Spring Security and the UAA, I can set it up really quickly. So in conclusion, you've got lightweight services. You're looking for lightweight infrastructure. You don't want to use anything that's too difficult to set up or test. Security is important, but it should be unobtrusive. That's a key message of Spring Security, right? We don't want it cluttering up our lives, but we do want it to work. OAuth2 is a standard, it's a spec, and like it or loathe it, it does what it says on the can, so it has a lot of useful features. Spring Security OAuth is a framework level implementation of that, so you can use that as a tool if you want to as well, but I would actually warmly recommend the Cloud Foundry UAA because it makes some choices that you would probably have to make yourself anyway. Okay, I mean, you might make them differently, but customize it, fork it on GitHub, whatever. Those are the links, so GitHub Spring Source for Spring Security, GitHub Cloud Foundry for the UAA, and then some blogs. There's been stuff on OAuth2 and Rest-ful web services on all of these blogs recently. So that was all I was going to show in terms of slides. I do have more code that I can show if I don't have too many questions, but are there any questions before we wrap up? Yeah? Can I use the UAA outside the context of Cloud Foundry? Absolutely, that's what I'm saying, right? It's a really good starting point. If you just download the code from GitHub and run it, Maven Tomcat run, you've got a system. If you do that, it's using an in-memory database. Okay, you want to change the configuration for that. That's easy, right? Yeah, but I mean, this is Spring we're talking about, so. Yeah, no, I'm positioning it as a general purpose authorization server. It is. And it has lots of nice features beyond just the OAuth2 endpoints, which I had 2 slides worth of that I couldn't go into a lot of detail on. But yeah, I think it's a good starting point for any OAuth2 provider. You could just take the sample apps that come with Spring Security and modify those. But I think you get further faster if you took the UAA. That's kind of what I would recommend somebody to do. Yeah. Extension for devices without keyboards, is that going to be part of the official standard? Well, what they've done with the official standard is break it up into little subdivisions, so that might be one of the ones that is slower than others to mature, but I mean, somebody's working on it. I think that's probably it's an interesting area of endeavor, shall we say, but I think the core spec is strong enough that you can adapt it in various ways. If you want to follow an official spec for that, that's great. But using a SAML insertion instead of an authorization code to get a token, that sounds like it's so blindingly obvious that should be possible. It's really easy to implement. The fact that it's not in the core spec shouldn't stop you doing it. And I think keyboard less authentication would be in that category. Yeah. Maybe 1 or 2 last questions. One last question. Anybody want to see demo? You want to have dinner, right?
Just one.
Yeah, go on.
The reason why I was asking those questions before is because we have an actual test case that we're thinking about implementing OAuth2, but from what you described, it's basically you don't have a lot of care for the resource. focus is on the user, not the resource.
Okay, so the question, can I paraphrase? I don't know. Yeah, he's saying the resource has to fend for itself, I quote. The focus is on the user or the client. It might have just been the way that I presented it. Because really, because that's a lot of the decisions we've made in the UAA have been to do with identifying the user and being careful about client registration. But actually, I would say the resource server is probably as well catered for in the spec as the other components. It's just that the spec doesn't tell you what information should be in a token. It really is up to you.
But you would have to figure that out basically on your implementation.
You would have to figure that out on your implementation. Yeah, I mean, you know what your business decision is for access decisions, right? You know what information you need, so make sure it's in the token. If it can be encoded as, you know, roughly speaking, users groups, then the UAA can already do it. If it isn't, then you're going to have to do database lookups to get more information about the user when the decision is made.
In this case, we would actually be our own authorization server. We would have one there as well.
Right. Okay. Thanks, everyone.